morning, this is B. Naresh, working as assistant professor in ECE department. Today we are going to discuss on definitions and terminology on module 1, that is diode applications. So in this session we are going to discuss definitions of some important parameters that is related to diode applications. So in that, the first one is, so define electronics, means what is the meaning of electronics. And we know that the branch of engineering, so this electronics deals with the conduction of the current through the vacuum or a gas or a semiconductor. So here the semiconductor means it contains a materials like N-type material or a P-type materials, and based on that it allows the flow of current from the one node to the another node. Now, the second one is, what is define conductivity. So means the conductivity means, so how much amount of conduction takes place across a particular device when a amount of force is applied. So that can be defined here. The conductivity is the ability of metal to conduct electricity when a potential difference, that is nothing but a voltage, is applied. Suppose, so let us consider, if you want to observe the conductivity of a normal PN junction diode, let us take, we know that this is the symbolic representation of PN diode. This is P-type material and N-type material. And for this PN junction diode, now we are going to apply some amount of the force. Let us take the force in terms of voltage here I taken, and how we are approaching this amount of the force to an PN junction. That is nothing but here, based on this amount of voltage is passing through a PN junction diode, then it allows the flow of conduction, or it allows the flow of charge across this device. So that should be measured in terms of conductivity. So let us take, when a positive pole is connected to P-type material and the negative pole is connected to N-type material, then this particular junction, we know that it acts as a forward bias. And how much means we need to identify that either it allows the flow of charge across this device or not. And based on this PN junction diode principle, we know that when the diode is acts as a forward bias, it allows the conduction across the PN junction diode. So that is the reason. Your applied force or input voltage must be greater than or equal to the current voltage of PN junction diode. Then the diode here acts as a short circuit. So whenever means this diode is replaced with, ideally it is replaced with a short circuit, means then we are applying the force. So hence the flow of conduction takes place from anode to cathode. So that is the reason it is ability to of a metal. So here this PN is actually one metal or a semiconductor to conduct the electricity, means how much charge is flowing through this device when we are applying some amount of the force in terms of your voltage. Now the third one is define voltage. So it is actually in generally in our electronics field, we are measuring some electrical parameters or the analog quantities. The physical quantities are measured in terms of either voltage or a current. So in this case, what is the meaning of voltage? Means a potential difference in a charge between the 2 points in an electric field. So this is an electric field. So means this is a potential difference between 2 points. This is one point and this is another point. Now here we are measuring the potential difference between these 2 points, and when you are applying some electric field, so that should be measured in terms of voltage, and the units for this voltage is represented as volts. So it should be represented as capital V. Similarly, then another physical quantity or another quantity in electronics field, that is current. So hence we are going to discuss what is means define current. So here the current is a flow of electrical charge carriers. Means the charge carriers, we are having the two types of the charge carriers, that is either electrons or a holes. So whenever you are applying some amount of the energy to an electron or holes, it will be repelling from the one direction to the another direction to allow the conduction. So that is the reason. So those charge carriers usually is represented as, but most of the cases we are considered the only electronics. So or you can also take holes. So that is the reason. So if you want to observe this one, let us take, we have the two materials. Let us take one is a P-type material, and due to this P-type material, the majority charge carriers are there here holes. So these are represented as holes. And if you consider another material, suppose N-type material, here the majority charge carriers electrons. So means, so these are the represented as electrons, and here it is represented as holes. So we know that the holes are positive charge particle and electrons are negative charge particles. For this positive charge particle, if you want to allow the conduction through this positive charge, means we need to apply the positive energy. Due to this approaching of the positive energy, the charge carriers are repelling from the one place to another place to allow the conduction. Similarly, if it is the electron is a negative charge particle, hence if you apply the negative force on this electron, then this electron is repelling from or diffusing from the one place to the other place to allow the conduction. That should be measured in terms of current. So most of the cases, the units for the current is should be represented as amperes. Now again, so another parameter is define resistance. So generally, in our any electronic circuit, we are going to use the resistance. So most of the cases, this resistance can be used to allow the means oppose the flow of charge or to limit the flow of charge. So here, that is the reason the opposition offered to the flow of electron. That means the electrons are generally the charge. So let us take this is our circuit, and any electron circuit contains. So this is some simple electronic circuit. Let us assume that the current is flowing through like this device, and due to this applied input voltage, then we are going to measure the output voltage across this device. So if you want to limit this flow of charge, then we need to use this recipe. As per according to Ohm's law, R is defined as it is a ratio of voltage to the current means. So this is R is inversely or means from this we can write I is inversely proportional to resistance. If you maintain if the resistance is small, the circuit offers very large current. If resistance is a large, the circuit offers very small current. So from that is a reason this resistance can be used to oppose the flow of charge or flow of electrons. Now define circuit. So what is the circuit actually? The circuit contains it is designed with some components. Like a circuit is a collection of real components, means we need to use in a real components like a passive components, or we are going to use some active components. So in a passive components we have the components like resistor, inductor and a capacitor. If you consider the active components are diode and transistors. Like apart from that, some power sources means either voltage source or current source, or like some signal sources, like AC signal source or DC signal source. So all are connected to, so the current can then flow in a complete circle. Suppose let us say this is the close means, so the circuit we need to make in a closed path. Whenever the circuit is in a closed path, then only the current is flowing from the one node to the another node. So to define the circuit means the circuit contains like your real components in terms of passive and active components and power sources as well as the signal sources. So by using all these sources, we need to make a closed loop network. That closed loop network is nothing but a completely it is called a circuit. So by using the circuit, we can define some applications. Now, what is electronic circuit? Means define electronic circuit. So this electronic circuit is a composed of individual electronic components. That is, like what we discussed in previous case, like passive components like resistors, capacitors, or inductors. If you consider some active components, that is transistors and diodes. So as per our this diode applications for as per our electronic devices and circuits, so all the electronic circuits is designed with like this passive components and active components only. So hence, so if you want to consider some like let us take one flipper circuit. If you take some flipper circuit, what is the flipper circuit? The flipper circuit contains, so this circuit requires a resistor and it contains a diode. Then it contains some sources like a voltage sources. So means if you are designing like this, the resistor, and then this is diode, then we are going to apply the voltage source V input. Now we are going to measure the output. What means this is nothing but a one complete electronic circuit. So to define our applications, suppose if you want to design a clamper circuit, so means it uses two passive components like resistor and the capacitor, and one active component is diode. Then like this is a resistor, and this parallel composition of capacitor and the diode. Then we need to pass some input signal source VI, then output measured across this capacitor. So this is the example for one electron circuit. The application is a clamper, and this is the one electron circuit. The application is clipper. So that is the reason. Both are means this type of circuits are all or belongs to your electronic circuits. Now define conductor and write few examples. So what is the meaning of conductor? Generally, a conductor is a material, and that material has a very high conductivity. Like we have the different types of materials. So we it means in that we have the conductors, semiconductors, and insulators. So out of these three, the conductor is the very sharp conductivity, means very high conductivity have. For this case, if you take some examples like copper, aluminium, and silver. So these are some materials, and these materials have some high conductivity, and means that it allows the a conduction across this device. Now, similar to that, define semiconductor and write few examples. So the semiconductor is actually in between conductor and insulator. So that is the reason it is called as a semiconductor. So a material is lies in between conductor and insulator. That type of the material is called as the semiconductor. And here also the semiconductor is also a allows the conductivity, means it has some own conductivity. So hence I represent it as a semiconductor is a material that has its conductivity lies between the insulator and the conductor. If you take the best example like silicon and germanium. So in that, so we know that silicon having some cut-in voltage if you want to define a normal semiconductor. So means semiconductor means a PN junction to define the semiconductor or to define a diode. This diode is made up with a P-type and N-type material. Those are belongs to silicon. So for this, the conductivity means the current voltage for silicon we have that 0. Some volts. So if the diode is made up with germanium, and at this point the cutting voltage for the germanium having the 0.3 volts. The next one is what is an insulator, and write a few examples. So this up to this one we just now we observed that what is a conductor and what is a semiconductor. So conductor is a very high conductivity, means very short duration. It allows the maximum, or it produce the maximum conduction. The semiconductor is always lies between conductor and the insulator. But here insulator is it does not allow the flow of charge, or there is no conductivity across this material, and that type of the materials belongs to insulator. So hence, a insulator is a material that offers very low level of the conductivity when the voltage is applied. So for this case, we taken as some the best examples are wood and glass. Means that this wood and glass does not allow the flow of charge, even though if you are applying the amount of force, or even though if you are applying the voltage. Now, the define intrinsic semiconductor and the write few examples. So, means the pure semiconductor is also called as the intrinsic semiconductor. What are the pure semiconductor materials like silicon and germanium, or the pure semiconductor materials? So, those pure semiconductor is also called as intrinsic semiconductor. So, that is the reason. A pure form of semiconductor is called as intrinsic semiconductor. Then the examples are silicon and germanium. Now define extrinsic semiconductor. So for a pure semiconductor, if you are adding some impurities to the pure semiconductor, then it becomes extrinsic semiconductor. So that is the reason. Here, the current conduction capability of intrinsic semiconductor can be increased significantly. Means if you want to increase the conductivity of the semiconductor, then we need to add some materials or impurities. Then we need to add some impurities to that particular semiconductor, intrinsic semiconductor, that is either silicon or a germanium. So that is the reason. The current conduction capability of intrinsic semiconductor can be increased significantly by adding a small amount of impurity to the intrinsic semiconductor. So based on this adding the impurities to a pure semiconductor, then it is becomes as a extrinsic semiconductor. So based on this extrinsic semiconductor, we defined as two types of the extrinsic semiconductor, that is called as a P-type extrinsic semiconductor. Another one is called as N-type extrinsic semiconductor. Means based on the doping concentration or based on the amount of impurities are adding to the pure semiconductor, we defined as these are the two types. One is a P-type, another one is N-type. Now we are going to define a diode. So what is diode actually? So here this diode is made up with two different materials. So in that actually we discussed that a P-type material and the N-type means that a trivalent impurities are added to the means trivalent means, so this trivalent means the third atom groups. Trivalent impurities are added with the pure intrinsic semiconductor, then it becomes a P-type extrinsic semiconductor. When pentavalent impurities are added with the intrinsic semiconductor, then it is acts as a N-type extrinsic semiconductor. Then by using these materials we are going to form a one junction. So means by interconnecting of this p-type material and n-type material is acts as a diode. So that is the reason it is also called as a p-n junction diode. Is a basically it is called as a semiconductor device. So means to define this semiconductor, just take a semiconductor. A half is doped with a trivalent impurities, then it is called as a p-type semiconductor. Another half is doping with a pentavalent impurities, then it becomes the n-type. So the intersection of these two materials is nothing but it is also called as a p-n junction, or it is also called as a normal diode. So hence here this p-n junction diode is basically a semiconductor device that controls the flow of electronic current in a circuit. Now, what is static resistance, and write the expression that is related to diode. So generally, the static means any resistance is defined as it is a ratio of voltage to the current. And here, the static resistance is absorbed under the forward bias. Means when the p-n junction diode is connected under the forward bias, means the p-type material is connected to positive of the battery and n-type material is connected to negative of the battery, then we can say that this particular junction is actually a forward bias. Under this forward bias, we observe the characteristics. The x-axis is represented as the forward voltage across the diode, and the y-axis is represented as the forward current across the diode. And when you are varying this V input voltage, whenever your applied input voltage reaches to just cut in voltage V gamma, then the conduction rate is increases. So for this case, at which the conduction rate is increases, at this point we are going to observe the how much resistance is offered. A particular Q point, how much resistance is offered. So this point indicates the static resistance, hence it is defined as VF, means ratio input voltage to the current, means the voltage across the diode to the current across the diode under the forward bias, means it is represented as the forward bias voltage to the forward bias to current. So hence the resistance of the diode at a particular operating point. So let us take this is some particular operating point Q point. So it is called as a static resistance. So that is the reason. The static resistance is represented as RF. So hence it is a ratio of forward voltage to the forward current of a diode at particular point, at particular Q point. So then that is the reason it is called as a DC resistance, or it is also called as a static resistance. What is dynamic resistance, and write the expression. So in the previous slide we observed the static resistance, and now we are going to observe dynamic resistance. Here this dynamic resistance is also called as AC resistance. To observe this dynamic resistance, we need to draw a one straight line between the two intersections, that is the maximum and the minimum values. Means, so let us take the VI characteristics of the PN junction diode. This is the diode forward current. X-axis is represented as diode forward voltage. Suppose if it is a Q point, then we need to draw one tangent line. So this tangent line intersects the 2 points. So this point is indexed at the maximum node, and at this point it defines the minimum values. Means this maximum contains maximum IF and the maximum VF, and this node also contains minimum current and the minimum voltage. Means the potential difference between these voltages and the currents, and that ratio is called as a AC resistance. And here this AC resistance is also called as a dynamic resistance, and this dynamic resistance is represented as small r. So generally we know that the resistance means it is the ratio of voltage to the current. Means here we need to change the deviation between the voltages and to the deviation of the current under the forward direction. So hence it is represented as delta Vf by delta If. So where delta Vf means it is represented as V2 minus V1 by I2 minus I1. So means the V maximum minus V minimum by I maximum minus your I minimum. So that is the reason it is represented as. So this is RF delta Vf by delta If. Now define drift current. So yeah, the drift current is also called electric current or the movement of the charge carriers. So actually in a diode we have the two types of the currents, drift current and diffusion current. Then when we need to observe the drift current and when we need to observe the diffusion current. So in this case, the drift current is absorbed when the applied force or when the force is applied between the PN junction. Means that is the reason. When due to that applied electric field, the movement of the charge carriers means the charge carriers are diffusing from the one region to the another region, hence it allows the conduction. The rate of conduction should be measured in terms of a electric current that is called as the drift current. So hence the drift current is the electric current or a movement of the charge carriers which is due to the applied electric field. So often it's stated as the electromagnetic force for a given distance. Now we need to define diffusion current. So here the diffusion current is absorbed under the absence of a external force. Due to that internal force, some of the charge carriers are diffusing or traveling from the one region to the another region or diffusing from the one region to the another region and then generate the flow of charge that should be measured in terms of diffusion current. So hence the diffusion current is a current in this semiconductor. The charge carriers, what are the charge carriers? Either holes or electrons. So this is the current which is due to the transport of the charge carriers occurring because of non-uniform concentration of the charge particles. So means we are having unequal dopings at the p side and the n side. Due to that, the non-uniform concentration of the charge particles, then some of the charge carriers are diffusing from the one region to the another region, hence it allows the conduction. That conduction here it is called as diffusion current. Now we'll see what is capacitance. So generally we know that the capacitance is the ability of a component or circuit to collect and store energy in the form of electrical charge. Means the charge is represented Q, so that is in terms of C into V. Means how much charge will be stored across the capacitance with applied electric voltage. Then define diffusion capacitance and write the expression. So here we have the two types of the capacitance like that in a diode applications. In the diode, based on the diode operation, we have the two resistances. One is static resistance, another one is dynamic resistance. And similar to that, and another resistance is also there, reverse resistance. Means this reverse resistance is absorbed when the PN junction is reverse bias. So when the PN junction is the reverse bias, it offers a resistance. That resistance is called as reverse resistance. So similar to that, and due to this biasing condition, the diode is also acts as the capacitance, and those capacitance are represented as diffusion capacitance. Another one is transition capacitance. Diffusion capacitance and transition capacitance. So now we'll see what is the diffuser capacitance. The diffusion capacitance due to the transport of the charge carriers between the two terminals of the device, that should be different. The CD is equal to the rate of change of charge with respect to the rate of change of applied voltage. Now we'll see define transition capacitance and write the expression. So what is the transition capacitance? So this transition capacitance is absorbed when the diode is reverse bias. So then the amount of capacitance is changed with increase in voltage is called as a transition. Means that is the reason. So if you observe the normal PN junction diode, so this is P, this is normal intersection point, this is diffusion region, depletion layer, and this is N type. When P is connected to negative pro of the battery and N is connected to positive pro of the battery, then what happens? Then VA is increases, then the depletion width is increasing. Means so if you observe the capacitor principle, what is the capacitor principle? Capacitor contains two conducting plates. In between the two conducting plates, one insulating media is there. Based on that, if your reverse voltage increases, the depletion width increases towards the battery ends. Let us, in this case, the P is actually the one conducting plate, N is actually the one conducting plate. In between these two conducting plates, it has the one a dielectric media. So why because it does not means due to this dielectric media, it does not accept the charge carriers from the P region to the N region or the N region to the P region. So we know that the C is inversely proportional to your distance between the two plates. So that is the reason. The amount of capacitance is changed with the increase in the voltage is called as a transition capacitance. So here also this transition capacitance is also represented as the rate of change of charge with respect to the rate of change of applied input voltage. Now in the diode applications, now we are going to define what is load line. So to identify the Q point of a particular diode, we need to identify the DC analysis. So means first we need to draw the characteristics of the PN junction diode, and x-axis is represented as the diode forward voltage, y-axis is represented as diode forward current. Then we need to plot the characteristics. Then we need to analyze the DC analysis. Under the DC analysis, we need to identify the two intersecting points. What happens when Vin is a zero? What is the current? If current is a zero, what is your input voltage? And based on that, we have the two coordinates. Then we need to represent the two coordinates in the characteristics curve of a diode, and that intersecting of the two coordinates of the DC analysis point, and that line is acts as a load line. So a load line is drawn on the characteristics curve, a graph of the current versus voltage. Means this graph current it also contains voltage versus current V versus I in a non-linear device like a diode. Then define storage time. So we have the diode switching times. So we have the diode means storage time, rise time, fall time, like that. So here the storage time means the time period for which the diode remains in the conductance state even in the reverse biased state is called as storage time. Let's assume if diode is on means if diode is on, then state is represented as if I means diode is on means the connection is. So when the diode is reached to maximum current, it will becomes your stable state. So means this is the time required to attain the maximum value when the diode is enters into the on state. When the diode is reached to the maximum state, it will be in a stable state even though if you are increasing the voltage. Then whenever suddenly the input voltage is falling towards the minimum voltage means under this point means diode now enters into the reverse bias, the state is off state. But here there is no sudden, if the input is suddenly decrementing, but there is no sudden decrement of output voltage to minimum, hence, but is slowly decrementing to a means. Even though if you apply the reverse voltage, then how much time period you maintain the same output means that time is called as storage time. So that is the reason. The time period which the diode remains in the conductor state when if the reverse bias in the state, even if the in the reverse bias state, the time is called as the storage time. Then we need to define transition time. Here the transition time is allowed to returning back to the state of non-conduction. That is, a steady state reverse bias is called as the transition time. Means how much time period is required to enter into the non-conduction state. So that time is nothing but a transition time. Means it changes from off state to on state. So on state to off state. So in previous example, we don't like this. Even when you apply the reverse bias, some time period maintains your previous value, then slowly restore. So here, how much time period is required to reach into non-conducting state, that is called as the transition time. And define forward recovery time. So here, the time required for the diode to change from reverse bias to forward bias means how much time period is required to change the state from the reverse bias conditions to forward bias condition is called as forward. That is called as forward recovery time. We need to define reverse recovery time. So here, the time required for the diode to change from the forward bias to reverse bias is called as reverse recovery time. Means how much time is required to change the state from the forward bias voltage to reverse bias voltage. That is called as reverse recovery time. Now, again, in the diode applications, we have some applications like rectifier and clippers, clampers, like that. So, in that, first, what is a rectifier? So, this is one of the application of the diode, and we know that the rectifier can be used to convert the AC signal to the pulsating DC signal. So, that is the reason. A circuit that converts AC voltage of a main supply into pulsating DC voltage is called as rectifier. Now, define PIV means here the PIV means peak inverse voltage. It is also called as peak reverse voltage. So that is the reason. Peak inverse voltage or a peak reverse voltage to refers the maximum voltage of a diode or other device can withstand in the reverse bias direction before break. Means generally we know that the PN diode is works under the forward bias condition only. If you are up with the reverse bias condition, there is no charge flows across the PN diode. But at a very large reverse voltage, it may be the diode may be get into the breakdown region. Means so before this breakdown region, without destroying any circuit operation or a diode operation, so that state is a means for this case how much energy is required to without destroying the diode operation under the reverse bias voltage, and that particular voltage here it is called as a peak inverse voltage or peak reverse voltage. Now define ripple factor. So by using this ripple factor, we are going to identify the how much AC ripples will be occurred in a pulsating DC output. So that is the reason. That should be observed by applying the mathematically the ratio of RMS value of AC component to the DC component in a rectifier output, that is known as the ripple factor. So means the ripple factor is represented as it is a ratio of VR RMS means this is the AC component to the DC component VDC. So this factor indicates the ripple factor. So by using this ripple factor, we can observe how many ripples will occur or how many ripples will be there in a pulsating DC output or from a rectifier output. Now define rectifier efficiency means generally. So the efficiency defined as it is a ratio of output parameter to the input parameter means output power to the input power. So the here the ratio of DC power obtained at the output to the applied input AC power means if you observe the rectifier circuit, whatever the rectifier circuit, for this rectifier we are applying the input signal, that is AC input signal, but output should be in a form of DC output power. So that is a pulsating DC output. So hence the ratio of the DC power obtained at the output to the applied input AC power means, so this efficiency is represented eta, that is the DC power delivered to the load to the AC power is applied at the input side. So that is defined as the efficiency of a given rectified circuit. Now we'll see one other application. Define clipboard means it clips or attenuates some portion of the given input signal. So means it clips or attenuates of a given input arbitrary waveform. So let us take, if it is my input signal, I need to clip some positive portion or a negative portion. Means I need to, suppose I want to eliminate the entire positive portion, means the output should be like this. So it removes this positive portion of the given input signal, or it maybe removes the negative portion of the given input signal. This type of the operation is done through one circuit that is called as clipper. So here, hence, a clipper is a circuit is designed to prevent a signal from exceeding a predetermined reference voltage levels. Now, what is biased clipper? A biased clipper is a clipper when a small portion of the positive or negative obstacles of the signal voltage to be removed. Means, suppose in a previous case, either we observe that either it removes positive portion, complete positive portion, or complete remove portion. But in this case, so let us take this is my input signal. Now I need to eliminate only some of the positive portion. Means I need to allow like this. So this dotted lines portion should be removed. Or suppose if you want to remove some information across the negative portion, means this dotted line indicates that there is a clip. So this type of the applications operation is called as a biased clipper. So for this case, we need to apply some reference voltages across the diode. That is either we need to apply positive reference voltage or a negative reference voltage. Now define cut-in voltage. So what is the cut-in voltage? So the forward voltage at which the current through the junction starts increasing rapidly means how much energies are required to make the conduction of a semiconductor device, and that particular point of voltage is called as the cut-in voltage. It is also called as knee voltage. So in the diode, it should be represented as V gamma. So the diode is made up with the two materials. One is silicon and germanium. For a silicon, the cut-in voltage is 0.7 volts. For a germanium, that is 0.3 volts. Now define clamper. So here, a clamper is an electronic circuit. Means clamper means either. So let's say this is a given input signal. Maybe your DC level is adjusted at either a positive portion or a negative. That is the reason the signal should be shifted towards either a positive direction or a negative direction. So from that, a clamper is an electronic circuit that fixes either the positive or negative peak expressions of a signal to a defined value by shifting its DC value. Means, so if I'm drawing like this, so at this point the DC level is adjusted at the positive side. Suppose if I am representing like this, so means here the DC level is adjusted in the negative portion. So this type of the operation is done through an electronic circuit that is called as the clamper circuit. Now what is positive clamper? So means that a positive clamper circuit is one that consists of So if you want to define a clamper circuit, it should be designed with a diode, resistor, and a capacitor. At this positive clamper, the entire DC signal should be shifted to the positive portion of the given input signal. So means shift the output signal to the positive portion of the input signal. So means that output voltage, entire output signal should be lifted and shifted to positive portion. This type of means here the DC level is adjusted at the positive portion. The way of adjusting this DC level at the positive portion, this type of the clamping, here it is called as a positive clamper. Similar to that, we need to define negative clamper. So in this case, the DC level is adjusted at the negative portion of the given input signal. Means the entire signal should be shifted towards negative side, or the DC level is adjusted at the negative clamper, negative peak. So hence, a negative clamper circuit is the one that consists of diode, resistor, and a capacitor that shift the output signal to the negative portion of the given input signal. So what is clamping circuit theorem? This theorem states for under any steady state conditions. So the clamping circuit theorem states that under steady state conditions for any input waveform, the ratio of the area under the output voltage curve in the forward direction to the in the reverse direction is equal to, so that ratio is equal to forward resistance to the reverse resistance is R. So means for any steady condition, the area under the forward direction to the area under the reverse direction, that is equal to the forward resistance to the resistance R. So this type of the statement is represented as a clamping circuit theorem. Now define comparator. So what is a comparator? Generally, it compares the two informations. A comparator is a device that compares two voltages RA currents and outputs to a digital signal indicating either which should be larger or should be smaller. Now, what is regenerative comparator here? So here the regenerative comparator means it uses a positive feedback. So whenever it uses the positive feedback, that type of the comparator circuit is called as a regenerative comparator circuit. And what is a non-regenerative means whenever it uses a negative feedback. So non-regenerative feedback is a circuit that uses the negative feedback circuits. Now the next one is what is doping. The doping means adding some impurities to the pure semiconductor for the increasing of the conductivity of that particular given material, that is called as the doping. So hence the process of adding the impurities to the intrinsic semiconductor is called as doping. So up to this point in this session, we observed that some of the definitions and terminology on Module 1, that is diode applications. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.